Wanted to welcome everyone to our latest webinar, IPTV Troubleshooting Tools, brought to you by our trainer extraordinary, Wes Waite. My name is Liz Rapley. I'm the Director of Marketing for Blonder Tongue. Just a couple housekeeping rules. If you have any questions, you can put them in at the chat or the Q&A buttons at the bottom of your screen. We will get to your questions. And at the end of the webinar, we will be sending out both the slides and the recording of this webinar via email, and it will be listed on our website. So with that, I'm going to turn it over to Wes.
Thank you, Liz, and welcome everyone to another installment of our webinar series. This one we're going to talk about the troubleshooting tools we can use for when we are trying to set up or troubleshoot an IPTV video system. So we're going to talk about things like the command line, things that we can do with the command line on our computer to help us determine if we're getting connectivity, and a couple other programs, some freeware such as Wireshark, some that do cost a little bit, like the MTSA Pro, that includes, a piece of hardware that needs to be connected to your computer to be able to decode and decipher the video stream. So with that, we will move forward here. If I can get my computer to advance. Hello. There we go. Okay, so first we're going to talk about the command line. It's a tool that's on all computers, laptops. It can be a good first tool to verify connectivity across your network. And I'll point out a couple of commands that we can use with the command line to help with that. Next is the Wireshark program. It's an IP stream analyzer. It is freeware. We can capture, record IP streams, not necessarily for you guys to decipher and figure out what's going on, but so you can capture some data that can then be sent in to us, to our engineers, for them to evaluate and help assist figure out what's going on with your network. Another piece of software is called TS Reader. It stands for Transport Stream Reader. There's a Pro and a Lite version. The Lite version is free, but it limits you in only being able to record up to, I believe, 2 minutes, whereas the Pro is a totally unhindered version. And also with the TS Reader, if you have a dongle or a device on your computer that you can see ASI or RF into your computer, you can also use TS Reader to evaluate those streams as well. The MTSA Pro is a module that we offer that has software associated with it. The module plugs into your USB on your computer, and we can evaluate RF, ASI, and IP with that as well. And again, it's good for evaluating the transport streams. Once all the RF issues have been resolved, if there's still issues with the stream itself, we can help evaluate that with the MTSA Pro, or you could record a stream and send it to us. We can evaluate it. All right, moving on to the command line. The command line, to get to command line from a Windows-based machine, you go into the search bar and or the run bar, start run, and type in CMD. That'll bring up these black boxes here that you see at the bottom of the screen. So the CMD pulls up the command, pulls up this command line box, And then if you type in a command such as IPconfig, like here, it tells us a little bit about our computer. It tells us our computer, when I took this screenshot, my computer IP address was 172.16.70.100, and the subnet mask, and I didn't have a gateway set up, and so on. If you type in IPconfig/all/all, it tells us a little bit more about the computer over here. It tells us the host name of the computer, the domain, the DNS suffix, and then here we see also the IP address again down here and the subnet mask. Those are the primary things we're looking for with the IPconfig command, is to find out what our IP address is so we make sure we're in the same network range as other things we're trying to talk to. Now, a common tool or a common command that we use in command line is ping. And ping, wondered what was ping an acronym? Did it stand for something? And I looked it up, and sure enough, it stands for Packet Internet Groper, is what ping stands for. So the ping command sends out a little bit of information, a couple bytes of information out to our destination, whatever we tell it where we want it to go, and sends that destination sends it back to us to let us know if it received it correctly or not. So here we did a ping to a 70.1 address, and we could see we had 4 successful pings of 32 bytes, took a millisecond or less each, and we didn't lose any data. Okay, here we go to, we can also ping, this is via my wireless card, to google.com, so we can punch in an internet name, and it will resolve that name. Google.com resolves to 74.125.226.3. So that tells me that my DNS, my domain name server, is working because it resolved Google.com to that 74 address, and then the ping worked out to it 4 times. Didn't lose any data. Okay. Now, this is all well and good, but this is either just sample pings. If you're working on a IPTV network, you primarily want to ping your encoders, your other devices on your network, on your local area network. So we have to remember that if we have a network and we're sending multicast IPTV signals around, a multicast address is kind of a virtual address on our network. It's not a true address of a device. So we don't want to try and ping the multicast address of a stream. We need to ping the actual address of a piece of equipment. Okay. Here's some options. If you type ping / it'll give you the list of options that you can add to the ping command, like a ping and then the IP address, and then -T would give you an indefinite ping. The default is 4. You can change the default count to do a -N and do 10 or do 100 pings instead of 4. The default is 4. You can change the size of the ping packets with a -L command. The max is 65,527 bytes. The default is 32 bytes. Okay, and you can see there's some other commands here. I wasn't going to go through all of them, but those are the most common. -T, -N, and -L are the most common that are used with the ping command. Trace route is another command that we can use with the command line. We can enter the IP address or the host name of the destination, and it will resolve the host name to an IP address. If you type only trace route, it will trace RT. It will give you a list of the options available. So with traceroute, each hop or each switch that the switch router that the signal goes through on its way to the destination, each one of those gets queried 3 times, and it lists the ping times. So from my desk, I did a trace to google.com, and the first thing it hit was this router here in our office, and it took 5 milliseconds, 1 millisecond, 1 millisecond ping, and then it moved out into the world, in through LightPath, Optimum Online, and then ultimately made its way to Google. Okay, again, if you're doing it on your internal network, you must put the actual IP address, just same as the ping command. You must put the actual IP address of the encoder or whatever you're trying to talk to, not the streaming IP address. Here we have one I tried doing a trace route to yahoo.com, and we see here at the 10th device, we have some asterisks. It didn't ping correctly. The request timed out. So the trace route then rerouted and looked for another path to get into Yahoo. Okay, and it wound up going through a bunch of their switches and routers until we got to the domain yahoo.com, this IP address, 98.138.253.109 is where we ultimately wound up. And that took us, from my desk, it took us 18 hops to get there. Went through 18 pieces of equipment. Again, there's the options for the traceroute command. So we do traceroute, and then the IP address or the host name, and then -D would be do not resolve addresses to host names, so it would speed up the trace a little bit by not telling you what the host name is for every IP address that you go through. The maximum number of hops to search for the target. If I only wanted to try to hit Yahoo with 10 hops instead of 18, I might put the -H trigger there to limit my number of hops. And then the wait timeout, how long am I going to wait before I time out and move on, try to get another route to my destination. Default is 4 seconds. Path ping is another command we can use. It's a kind of a combination of the ping command and the traceroute command. It will take a few minutes to perform, but what it does is it pings every hop from the source, every router from the source to the destination. At every hop, it does it 100 times. So it tells us if it was successful, how many. So we had 0 lost out of 100. So we lost 0% on this one. Same on this one. It records and displays our results, and it can help us determine if there's issues on the network. So here we're doing a path ping from my desk to our domain, blundertongue.com, and it shows it's got 2 hops to go to get there, and it got there no problem. There were no issues through the pings. Okay. Now if we look here, if we try to path ping to Google from our office, between at port 6 or at position 6 here, we see we had 100% loss. So it did not ping. It didn't. It might not. It might be the device might be set up to not allow pings, and I tried to ping it 100 times, so it may not allow it. But on your internal networks, you should not have that kind of a problem. And also notice the higher route trace time, the RTT. This column here goes up as further we get out into a network. Starting out with 3 milliseconds, by the end we're up to 8 milliseconds for the route to happen here. Here's the options list for the path ping command. Some of the more common ones, again, -N. So it does not resolve the DNS resolve all the addresses. -P gives us the period, the wait period between pings in milliseconds. -Q gives us the number of queries per hop. Again, the default for that is 100 pings. And then -W is the timeout, the wait timeout is set for 3 seconds on this path ping before it times out. So that's a couple. I mean, they're not be all end all tools, but a couple tools that will help us make sure that our network is together and we can talk among different things. Now we're going to look a little bit at Wireshark. Again, Wireshark is an open source program that can be very useful to help us determine what you can take recordings with it and send it to us, and our engineers can evaluate it and help decipher what's going on with your network, why you may or may not be having issues at a certain area in your network, or what have you. So here's the main interface with it. Basically, you have to select which port on your computer you're going to use to trace. If you've got a laptop, you may have a wireless port as well as a hardwired port, so you can select multiple, you have multiple choices to select which interface you're going to use to capture from, and then start the capture by hitting the green shark fin here. So prior to starting a capture, you could set up a capture filter. A capture filter would allow you to minimize the amount of data that you're going to capture by, for example, in this example up here, I'm saying capture only any data that's coming from this IP address, 239.16.180.56. So if I'm on a corporate network, for example, and I know there's a lot of other traffic on that network, I may only want to see the data that's coming from this multicast address here, okay, and capture that. When you set up a capture filter, it's only going to look at and record the packets from that apply to this filter. So any other data that's on your network, Wireshark will totally discard, totally ignore, will only show and capture data from this IP address. All right, you cannot at any time go back and see any other packets. There is another filter once you're done capturing. There are view filters that would allow you to hide other data, but you could then undo the view filter and see that other data again. With a capture filter, once you set up a capture filter, that's it. That's the only information you're going to receive. You won't have any chance to view any other data. Okay, but it does produce a smaller file size. It is not recommended to set up a capture filter if you're capturing data for us, for our engineers to view, to evaluate, just because we like to see what other data is on the network, just to understand what else is going on with the network and what might be causing issue. Okay. Some common filters when evaluating IP video traffic. You saw the IP.ADDR, so the specific source or destination IP address, or specifically a destination.dst or a source .src address. So if you know that you only want from this specific source, you can say IP.src equals and the IP address, and it will only provide data, show data from that source. Other filters syntax is the UDP. So you can do a specific UDP port, or you can do a UDP destination port or a source port. Okay, we can also string together multiple, oh no, sorry, that's the next slide. So the operators in the filter stream equals, you can do the words EQ, or the equal sign twice is equal to that IP address or what have you. Not equal to, greater than, less than, greater than or equal to, less than or equal to, and so on. Okay, there's a whole community out there dedicated to helping people with working with Wireshark. So there's a lot of resources for setting up and working with Wireshark out there. Here, multiple filter strings can be put together. So you can do an or, an exclusive or a not. For example, IP address equals this, an exclusive or, meaning it equals, the IP address equals one or the other, but not both. Okay. So for example, if IP address is that, exclusive or, the port number is this, but not both, for example. Or we have the IP address equals that and the port number equals that. So if this 70.20 address is sending other traffic aside from UDP multicast traffic or UDP video traffic, it would ignore that and only show the information coming through on port 50,000. So here is an actual piece of a Wireshark capture. It happens very quickly, and it scrolls through the top half of this screenshot here. The bluish part is the actual, each line is a packet of data, and then below the center line here, below the center line here, is the breakdown of what that information means. So here I'm looking at this, I believe I'm looking at this line here, 5970, and yeah, frame 5970, and this is breaking down what is on that video stream right there from that packet. Okay, and this here is showing the program association table or the PAT table. This is a breakdown of the program association table. So it tells me what streams, what PIDs are on my my programs, what PIDs my programs are set to, and how they're associated in the program association table. There's also a PMT, a program map table in the stream, and that's this, showing me the elementary PIDs here, the elementary stream length, audio information. So this up here is video information. This down here is the audio information. Okay, but that all breaks down and tells me, and again, we don't have to identify all of that information. We basically, if we're having an issue, we want to get a capture of it, get the customer to get it to us so that our engineers that know how to evaluate and break this down can do so and help figure out what the issue is. And then this is the actual video stream here. We see that's the video stream that we're looking at. So all this information here is the PES headers, the program elementary stream, headers, data, and then all the data within the header, underneath each header. And then there's another section here I kind of closed up on the main part here and even the breakdown part. It even breaks it down further than that. Here's the message fragments of a video data stream. Here's the raw data from the video stream. So you could even get down to seeing it that far, but who can really decipher that? Not too many people. So again, and then there's the audio stream, same thing. Again, so we primarily want to use a tool like this to capture streams, capture information. If we're having momentary glitches or tiling or breakup of our IP video streams, we can use a tool like this to capture that incidence and get that information to our engineers to have them help us identify why that might be happening. So in Wireshark, we want to save the file as. We want to save it as a .pcap, PCAP. The default that the program wants to save it in is a PCAP NG, but from what I understand, it truncates some information in that format. So we like to see it, our engineers like to see it in the .pcap format, which is up here on the list. It's the second item on the type list, the choices. Okay. Now we're going to look at the MTSA Pro. The MTSA Pro, again, is a physical piece, a piece of hardware that connects to our computer and allows us to evaluate streams somewhat similar to the Wireshark program, but it's a little more powerful. With the MTSA Pro, we can evaluate, the Wireshark can only evaluate IP streams. With the MTSA Pro, we can evaluate IP streams from the IP input on our computer. We can also evaluate the QAM or 8VSB RF streams directly from our cable feed or off-air feed, an ASI signal from our ASI source, and again, this plugs directly into our computers with a USB. So here's the MTSA software. The MTSA software only opens up when it senses that a MTSA hardware device is plugged into that computer. So you can't. The software is available up on our firmware drive, but it's only available to use when you have the MTSA Pro hardware attached to your computer. So here first, when we're first connecting to a device, a stream, or an RF signal, we have to come here and determine what kind of input are we going to have. We can also evaluate if we have a recorded stream. We can open a file or a transport stream in from the ASI or IP in or an RF input. Okay, so we have to select which one of those we're going to work with. Let's say we're working with first an RF input. It gives us some choices. Are we going to run 256 QAM or 8VSB or 64 QAM? Is our spectrum going to be inverted or not? Spectrum normal? Most, believe it or not, most systems in the US do run spectrum inverted. So that's where we want to be set up. Then are we going to select what we want to look at by a channel number, like a cable channel number or a terrestrial channel number, or are we going to tune to it by frequency? So So we set all that up. We selected 256 QAM, inverted spectrum, cable. In this case, we selected cable channel 15. Okay, and it says down here that we're locked. We have a good MER. It tells us the MER. It tells us what my input level is on that channel. And the other option for coming in, let's say we're going for an IP input. We select which network adapter we're going to use to look at the IP stream, select the protocol. Most primarily, we're using UDP/RTP, the IP address of the stream we want to look at, and the port number that we want to look at. Once we've selected all of that, then we go ahead and hit the play button over here, and the play button starts to play out this stream. Okay, and in this particular stream now, I've got a couple of different programs. I've got a program up here. I've got a second program down here. I probably have a third or fourth program. I've got a third program here. So this one has, in particular, 3 programs. Looks like one of it is clear, unencrypted. The other 2 show locks here. So I won't be able to view the encrypted signals here with the locks, but I would be able to view the first program. Okay. Now we've got a couple of modes, different modes here. Under this mode here, the mode button, we can look at it in ATSC mode, which would sort things by the channel number and the short name description. Okay, so here we see we've got 2.1, CBS, 13.3, 13.2, 13.1, and so on. Here in MPEG-2 mode, we're only looking at the program numbers and then the PIDs, just the program number data. So here we see 2C9 over here is NETHD, is 2C9. Well, when it resorted it, 2C9 wound up down here at the bottom. Okay, so it's just a little feature whether to look at the RF channel numbers and short names or not. All of that we were looking at over here in the services tab over here. Now we're looking at the service view. We can see we actually do get a play out of the video that's playing, so we can see live what the video is here. And again, that's whether we're looking at an IP stream, an RF stream, what have you. You can also blow this up, so this will take up, I believe it's half screen is the largest it'll go. But there's other information here too as well. We can see some of the technical report information, some of the errors will display down here and tell us it looks like everything is in the green right now, except for my laser pointer icon is red, but everything down here is in the green, so that's good. Okay. And other things we can see across the tabs here, we have the bit rate, so we can see the bit rate, the breakdown. We have 3 programs. They're all taking up about 30% of the information. The total bit rate, 38 megabits. So, and we have the extra stuff is, etc., is null packets and the tables and whatnot. Okay, so the bit rates you can see here, we've got a different channel we're looking at. So we've got probably a couple of standard definition programs, then a high definition program. It takes up a lot more of the data. Okay, and then, yeah, so if we look down here at the list, numbers 1, 2, and 4, well, 4 is actually an HD channel. It's not as HD as channel 2, 2.1 CBS HD, is this one taking up almost half of the allocated bandwidth, and then the 13.1 takes up about a quarter of it, and then the remaining bandwidth is split among the standard definition programs. Okay, I mentioned a technical report. There's the TR-101290 is a technical report that tells us about the health of a transport stream. Again, whether it's being transported on RF or IP, this transport stream errors tells us a lot about the health of the signal. So here, priority 1 errors is most likely going to cause issue with signal display. You can get tiling, breakup, jitter from a priority 1 error. Priority 2 errors may or may not cause picture problems. So the customer may not see if there's a PTS error, for example, 2.5. If there's a PTS error, the customer may not see that. Okay. And priority 3 errors, this is an unreferenced PID. So there's an unreferenced bit of data coming across that we don't know what to do with. Well, that's not going to cause picture issues. Okay, but this will tell us if we did have priority 2 or priority 1 errors, this would tell us about it, and then we'd have to determine how to go about correcting that. Here's a list, and again, as Liz mentioned, she was going to send an email out at the end of this. It will also be posted. A PDF version of this will also be posted, and the recording of it will be posted on our website to be viewed at a later time. But this shows an overview of what the TR-101-290 errors are: transport string sync loss, sync byte errors, program association table errors, and so forth, and how essential they are to, so 1.2, a sync byte error may not necessarily prevent decoding of content. So you may or may not have an issue with picture quality there. Okay, then we move on to table history. Table history, basically it breaks it down like in Wireshark. You can break it down to the raw bits of data. Now for the MTSA Pro, setting up a recording is a little different. Before we start playing the recording, we need to come into the settings and set up our recording setup. So we can set it up to do a record time and record it for a specific amount of time. We can record it for a specific file size in megabytes, okay? And once we do that and determine what path we're going to save it to, and once we set that up and start playing it out, then we can come over here and hit the record button right here, hit the record button, and it will start recording. And down here it's telling us it's recording. We're about 20 seconds into it, and what the total storage file size is so far. Okay, and if you've got it set up to record for a certain time or a certain data size, then once it reaches that, it will just automatically stop recording. And the third thing I wanted to mention today was the TS Reader, Transport Stream Reader. There is a light version available on their website. This again shows all the PID data, the tables, etc. It does show you some of the errors down here in this section. It is not quite as extensive as the MTSA Pro, but it does show you some of the errors. It shows you if you're getting some errors. You can record and playback streams from the TS Reader program. Again, the TS Reader Lite program is limited to about 2 minutes worth of recording or playback before it shuts itself down. And then there's a full pay version. You can also have a QAM or an 8BSB tuner to be able to see RF information, and that can also be used with the TS Reader as well. If you had this running, if this was live and I was over here, this is just a static screenshot, if you will, of the video. But if I clicked it, it would open a VLC Media Player to play it out live on VLC Media Player. Again, that only works on the light version for 2 minutes, and then it will stop itself. But again, here in TS Reader, we can record a program, We want to record all programs, and again, a 2 to 3 minute stream, and you can send it to us for evaluation. Now, sending the record, I've mentioned it several times, sending the recordings to us. Again, we want the Wireshark recordings saved as .pcap, not PCAP-NG. We don't want to add any filters to our Wireshark recording unless you've already spoken to us, myself or John, and we've specifically asked you to add a filter to a Wireshark Capture. The Wireshark, the MTSA Pro, or the TS Reader recording should be about 2 to 3 minutes long. We don't just want a little 10-second clip, because then we may or may not capture the issue, and it's very difficult. Even if it does capture the issue, it's very difficult with a 10-second clip to properly evaluate it. Okay, so we need at least a couple-minute clip. We also want to know what equipment is generating this transport stream. The model, the brand. We want a diagram of the network, including switches, routers, whatever's in the network, and where in the network the captures are being made. We like to assume that captures are being made as close as possible to the source, or as close as possible to the destination that's having the issue, if it's only one place having an issue, but that's not always the case. So we need to know where on the network specifically the captures are made, and hopefully you might have even captured it in several different places. And what is the issue? You know, you may send us 3 or 4 captures and say, here you go, this is my issue. Well, we watch it back and see no issue. So we need to know what kind of we're looking for. If there's a microsecond of a glitch happening at 32 seconds into your capture, we need to know that so we can specifically look for that. All right. And like it says here, we're only going to evaluate Blonder Tongue Drake product produced transport streams with no charge. We will look at, in some cases there are other devices that generate the stream that comes to a Blonder Tongue device or a Drake device. So we're trying to help you troubleshoot it, and want to help you get your system up and running. But if we find that the non-Blonder Tongue or Drake product is the one that's causing the issue, we may say, hey, we know what your problem is, but we need to get a little compensation for helping you solve somebody else's problem, right? So we may charge a fee for that. The contact for sending captures, so you want to send us an email, not with the capture attached, but just send an email or call us and get a dialogue going first. And once we establish that dialogue, then we will give you an FTP link to be able to upload the capture to, because the capture can get very large. It can get gigabytes large. Okay, so potentially, depending on how long of a capture we get. So it's not going to go through an email. We got to get a dialogue going, either through tech support at Blonder Tongue, or call the main number down here at the bottom of the page and go for tech support, and we'll help set you up with an FTP link so that you can get it uploaded to us, and we can get our engineers to look at it and help resolve any issues. Our tech support also remotely assists in encoder setups and troubleshooting of network issues. I spent most of this morning helping 3 or 4 different customers initially set up units and do some troubleshooting as well. We primarily use TeamViewer version 12. I know it's an older version for those of you that are familiar with it, but we have a licensed version of TeamViewer 12, and we're sticking with that licensed version, so we can't connect to the new TeamViewer 14 or 15, whatever it is. So we ask our customers to downgrade to TeamViewer 12 so that we can connect. Or GoToMeeting or some other platform we've used. Actually, I think we're starting to get away from GoToMeeting, but we have a couple other platforms we use to help assist dial into customer computers and help set up. So contact us. We'll get you set up so we can get connected. And the remote computer we're trying to dial into must have internet access and local access to the encoders. So if your encoders are not on your local intranet and they're just standalone, you would need something like a laptop that you can hard line to an encoder and also have Wi-Fi on the laptop going out to the world so that we can come in through TeamViewer or some other method into your laptop and then be able to go hardwire from your laptop to the encoder to be able to help set you up and troubleshoot and whatever, okay? Again, no fee for Blonder Tongue products. All support, phone support, remote login support is Monday through Friday, 8:30 to 4:30 Eastern Time. And with that, I now open it up. Thank you all for coming and open it up to any questions. Liz?
There's one question that was asked, is the MTSA Pro made by Deck Tech?
I believe it is, yes. It's either Deck Tech or Lumen Tech. I do not recall which. But yes, it's not made by Blonder Tongue. It's a third party hardware.
Will this be available for reviewing? Yes. As I said in the beginning of the webinar, we're going to be emailing out a copy of the video recording of this, and as well as the slides, and you can also find them on our website. How much is IPTV used? Question came in.
It is getting to be more and more. I know one of our local school systems is Blonder Tongue has had a relationship with the local school system for many, many years. We have had a support contract with them for 10 plus years at least to assist them in maintaining their RF network. And I know recently, and I know the gentleman is on the line here with us, and he's probably chuckling to himself. And I know they have recently moved from RF to an IP network, and I applaud them for that. But I am seeing more and more people. I don't think in the next 10 years, I don't think IPTV is going to take over RF. I personally, I really don't see it, but it is becoming more common, is all I can say.
Okay. Do you have a recommendation for a good tap to use with Wireshark?
For a good tap to use with Wireshark?
Yep.
I don't know what that means by a good tap to use with Wireshark. Wireshark, you plug your computer Ethernet into the network, and Wireshark is evaluating and recording all of the data that hits your computer. So I'm.
Okay.
Somebody else
to that, somebody said Dualcomm makes a good Wireshark tap.
Okay, there you go.
How much is the tech service capture device?
The transport stream capture device.
Transport stream, sorry. I live in a different world of acronyms.
I know. The capture device, are we talking, if we're talking about the MTSA Pro, I don't have, honestly, I'm in technical support. I don't have pricing.
You can look at the pricing on our website.
But there's pricing on our website. I assume we're talking about, I'm trying to get back there if I can, the MTSA Pro is the transport stream capture device that we offer. And that is here. Too far. This guy. And that is available. You can see it on our website for pricing. I don't know offhand what the number is. And
Alex, you are also asked how to purchase this. If you work with any of our premium distributors like Turner Cable or Advanced Media Technologies or Nicholas Shermer or Mediacom or Multicom or Megahertz, you can purchase it through that. You can also purchase through the website. You know, there's a lot of different ways to purchase. So if you want to reach out to us offline, we can help you out there.
I see there's a question. What media transports are best used to the TV, i.e. one Cat 6 or 2 or other? Well, I don't know that I'd say one is better than the other. Well, one Cat 6A or 2 or other. I don't know of a system that's running 2 Cat 6s or 2 Ethernet ports to a television. It's primarily going to be one. Again, I'm still seeing, I'm from the RF world coming into the IP world for IP television, and I still see it from the RF side. On one piece of RG6 or RG59 coax can handle much more, many more channels of video than a piece of Cat 6 can, in my eyes. So which is, again, why I don't think IP television is going to overtake cable television, CATV, coax cable in the near future anyway. But what are best used, I don't know of many televisions that have direct IP input currently. I have not personally been television shopping in a couple of years, but I still don't know of any that have IPTV inputs. I know there are set-top boxes that have it, but not televisions. So I think coax is still the primary player in this game.
There's one other question in the chat area.
Okay.
You see that at the bottom?
I didn't see that one. I didn't see that one. Chat area.
For MoCA networks, we do pure IPTV, but in many locations we have MoCA distribution with coax cable.
We do not have tools for MoCA, no. No. Multimedia over coax architecture. I know what it is, but no, we don't have any specific tools for that.
Okay, if there are no other questions, we just want to say thank you again to everybody who has participated in our webinar series. And stay tuned, we'll probably be back later in the summer with some more opportunities to learn. We will be sending out this video, and just check our website for any additional information. Thank you so much. Have a great day.
Thank you all.
All right. Bye.